Howdy, howdy. So we are about to take a look at this problem that I gave to you on Tuesday in class. A few things to consider here. So your 45-year-old female client weighing 145 pounds completed her YMCA step test. Okay, you need to make sure you're reading the whole question. So after she did that, she wants to try and take Miss Collins' actual step class at the YMCA. She hasn't been active lately. What would your recommendation be for how many risers to place under her bench to ensure that she is working at 60% of her VO2 max? So 60% of her VO2 max, estimated VO2 max would be here. We're going to play a little bit with this, taking it a little bit further. So if you're taking 60% of her VO2 max, because we need to find out that intensity, you would simply take 30 mils per kg per minute times 0.6. Okay. And of course, I'm going to have to use my little calculator. And this video is probably going to make you dizzy. Let's see. Eekies. So what was it? 30 times 0.6. So that would be 18 mils per kg per minute. Now, you could also look at VO2 reserve and use a percentage of her VO2 reserve as a way to gauge intensity. And that accounts for that 3.5 milliliters of oxygen per kg per minute that everyone pretty much on the planet, unless you have some type of metabolic issue, that's the amount that they're consuming when you're just sitting doing nothing. So you and I right now, we're probably sitting in a chair doing nothing, and we're consuming 3.5 milliliters per kilogram per minute while we're doing that. So to get a little bit more accurate representation of the intensity, accounting for that resting value, you would simply take 30 mils per kg per minute and subtract that 3.5, that resting value. And this should remind you of the heart rate reserve method as well, right? Same type of deal. So that would leave us with 26.5 mils per kg per minute. And then we would take our percentage from the VO2 max reserve value. Okay, let's see what that equals. I don't trust my mental math. Been doing mental math with my daughter. She's in 3rd grade. And I'm like, oh, have I gotten used to a calculator? So that gives us 15.9 mils per kg per minute. And then, of course, we would need to add back our resting value. And that would give us a little bit better intensity, because we're accounting for that resting value. Okay, so 15.9 plus 3.5 would give us an actual VO2 of 19.4 mils per kg per minute. Now, read your question. Read your question, read your question. They did not ask us to use relative VO2 max. They asked us to use regular VO2 max as a predictor, okay, of intensity, or a quantifier of intensity. So in order to get credit for this question, let's say if it was an exam question, you need to read very carefully. While this is a preferred method, they didn't ask you to use relative VO2 max. They asked you to use VO2 max in determining your intensity level here. So we're going to go with 18 mils per kg per minute when we're using our step equation, which we're going to look at in just a second. So 18 mils per kg per minute. That's our percentage, 60% of VO2, predicted VO2 max. And then the relative VO2 max would be 19.4 mils per kg per minute. So just be prepared. First, we're going to work the problem using this value. Then we're going to work the problem using this value and just see how that shakes out.